All right, everybody, to continue our radicals section, we're going to be talking about quite a few properties that you can use with radicals. So the first one we're going to start with is the product property. Basically what this says is that you could have two radicals of the same index, for example, square root of 2 and then times the square root of 8. And if it's the product or the multiplication of them, then I can combine those into one. So I can take the square root of 2 times the square root of 8, and that would be the same as saying the square root of 16. And then I could simplify that down to equal 4. So what it says is that you can combine or multiply the radicands if the roots or the index are the same number. All right, so same thing would apply if I had the cube root of 8 times the cube root of 5. I could multiply those together to get the cube root of 40, and then I would simplify as much as I can. Okay, so let's look at an example here. Let's say we have the square root of 32x to the 8th. Now, please keep in mind that this product property goes both directions. So not only can you multiply them together, but you can also break them up in order to simplify something further. So when you look at this example, we have the square root of 32x to the 8th. Notice that 32 is not a perfect square, so I can't take the square root of 32 nicely. So this is what we've practiced before, where you're going to take the square root of 32 and you're going to break it down into its perfect squares. So we could take the square root of 4 times the square root of 8. Okay? Or we could even go higher, and maybe we can do the square root of 16 and then the square root of 2. Remember, you're multiplying these together, so 16 times 2 is 32. Now, because I've broken it up using the product property, I can simplify. Well, what's the square root of 16? That's 4. Well, the square root of 2 I cannot simplify, so I'm going to leave that as square root of 2. And then I have to work with the variable. So remember, like we did in the last video, you want to look at your exponent and divide. So 8 divided by 2 gets us 4. So that means we're going to have x to the 4th. Now notice, because it was a nice whole number, that it went outside of your radical sign. So I have 4x to the 4th times the square root of 2, and then we'd be done with this example. All right, so do the numbers first, then deal with the variables second. Okay, let's try one more example. Let's say we've got the 4th root of 16, a to the 24th, b to the 13th. So again, start with the number in front. So we're going to have the 4th root of 16. If you don't know what the 4th root of 16 is, remember you can rewrite that as something to the 4th. That will get you 16. In this case, 2 to the 4th gets you 16, so we're going to have a 2 here. And so I've done the 16, now I move on to the letters. So we have a to the 24th. Well, I can divide. 24 divided by 4 gets us 6, so I'm going to have an a to the 6th. And I'm going to do the same thing for b. So take 13 divided by 4, but 4 doesn't go into 13 evenly, so we want to figure out what the remainder is. 4 goes into 13 3 times, because that gets us 12. And in order to get to 13, we're going to have 1 left over. So this is where it's really important to pay attention to your numbers. The 3 tells us how many we have outside of the radical symbol. So we're going to have a b to the 3rd. The remainder tells us how many are going to be left underneath our radical sign. So we're going to have the 4th root of b to the 1st. Okay? So you did the whole number first, or the front number out in front first. Then you do all your exponents, and if you have any remainders, those go underneath the radical sign. All right? So if you have any questions about those, make sure you let me know. The division property of radicals says that you can take a radical that has a fraction in it, or division, and you can split it up into two separate parts in a fraction. So I've got this written here in the generic terms. So the nth root of a over b is the same as the nth root of a over the nth root of b. So you can treat them as one whole fraction, or you can treat them as separate individual radicals, one on top, one on bottom. That can be very helpful when you're needing to simplify. An example of this might look like the square root of 27 over the square root of 3. Well, obviously we can't take the square root of 27 or the square root of 3 nicely. However, this division property rule says we can morph that into one big fraction, and because we can do that, we can reduce the 27 over 3 into the square root of 9. And the square root of 9 obviously is 3. So taking something that was very ugly and that didn't reduce nicely, by combining it into one division problem, we could reduce it down to something that works out very well. All right, so there's an example where it's helpful to combine it. You could also have it go the other way, where it is 1, so maybe the cube root of x to the 6th over 8. Can't reduce that very easily. You can't divide x by 8, so to split it up actually makes it easier to reduce. So we're going to split it up into the top and the bottom. So now if I take the cube root of x to the 6th, remember we divide our exponents, so 6 divided by 3 is 2, so I'm going to have x to the 2nd on the top. And then on the bottom, the cube root of 8, so what to the 3rd gets you 8? Well, that's going to be a 2. So now my answer is x squared over 2. So it looked really complicated, but I broke it up and then I was able to reduce them nicely. Now, these are examples where using this rule makes it really easy to solve. However, sometimes you're going to have to do what's called rationalizing a denominator. And this is when you can't reduce the denominator completely, and you cannot leave a radical in the denominator. So let me add that here. So you cannot leave a radical sign in the denominator. That's important. When you are trying to rationalize a denominator, the key is making sure that your radical signs will eliminate completely. So here's an example. We'd have the square root of x to the 6th over y to the 7th. Obviously we can't divide these, so we're going to try to break it up. So x to the 6th and y to the 7th. By doing that, we can actually reduce the top pretty easily. 2, remember there's an understood 2 that goes here. 2 goes into 6 evenly. However, 2 doesn't go into 7 evenly. So the problem is we won't be able to reduce the denominator. We're going to still have a radical in it. So the trick is to make the denominator have an exponent that goes into, that 2 can go into evenly. So to do that, we're going to do some multiplication. So 2 doesn't go into 7 evenly. However, 2 does go into 8 evenly. So if I multiply in another square root of y to the 1st, so square root of y to the 1st, then what that does is it leaves me with a square root of y to the 8th in the bottom, because 7 plus 1 is 8. When we add, or when we're multiplying, we add exponents. And then on the top, I'm going to have a square root of x to the 6th y. And now, even though it looks more complicated, I can actually reduce the square root on the bottom much easier. So when I do that, remember there's a 2 here. 2 goes into 8 4 times. So in the bottom, I'm going to have y to the 4th. And because I have no radical sign in the denominator, that's a good thing. And then on the top, I can reduce as much as I can. So 2 goes into 6 3 times, so I'm going to have x to the 3rd. But 2 doesn't go into 1 at all, so this is going to stay the square root of y. And this would be our final answer, where we have rationalized the denominator and we only have nice whole exponents in our denominator. Okay, so if you have any questions about rationalizing, please let me know. If you want to try this example here below on your own and see how you do, let me know if you have any questions. So the 5th root of 3 over 4y. So again, break it up into your top and the bottom, and then remember you're going to be multiplying by something on the top and the bottom so that you can reduce the denominator completely where there are no radicals. That might mean you have to multiply the 4 by something and the y by something so that you could take the 5th root of it. If you have questions, let me know.